Before we begin the lesson today, I want you to take a moment, pause this video, and write a list of 5 tools that are used in modern-day society, say to build houses, prepare a dinner, or when we go hunting. Here is my list: hammers, knives, drills, saws, and the bow and arrow. Today, we will be discussing stone tool use in prehistory. And as we go through the lesson, I want you to connect the tools today to the tools used in the past. Stone tools can be chipstone tools, like arrowheads or knives, or created from ground stone, or stone that has been sanded and worn into a specific shape. The first stone tools were created 2.6 million years ago in Africa, created by hominins known as Homo habilis, also known as the handyman. These tools are part of an industry or a set of similar tools known as the Oldowan industry. These are simple tools formed by taking chips off of cores or large cobbles of stone to create a sharp edge. These tools are primarily used as hammers or axes to smash bones and tubers. They are choppers. As time goes on, stone tools are adapted or changed to suit new purposes and needs. This is a gradual change, usually accompanied by a shift in lifeways or environment. The Acheulean tool industry was developed about 1.7 million years ago by Homo erectus, another one of our non-human ancestors. This hominin was the first to move out of Africa. Compared to Oldowan tools, Acheulean axes are more sophisticated in their manufacture. A larger rock, or a hammerstone, was used to knock flakes off the edge of a core systematically so that it is chipped on multiple edges on both sides, meaning these are bifacial tools. Smaller flakes were taken off with a bone or a piece of wood to shape and sharpen the tool. These Acheulean hand axes are often shaped like pears or teardrops. Acheulean tools were made for slicing, skinning, digging, and cutting. They are truly multi-purpose tools, which is a hallmark of many stone tools that we will discuss today. The Musterian industry arose around 200,000 years ago by Homo neanderthalensis, a close relative of ours who lived primarily in East Asia and Europe. The Musterian tool industry was based around the production of small blades created by removing flakes from a paired core. This method is referred to as the Lavoie technique. The flakes could then be shaped into scrapers and knives, like tools that could be used to skin animals, and could also be attached to long rods to form spears for hunting. As you can see, over time, tools change, usually as adaptations to different surroundings and different ways of life. Stone tools can be formal, meaning they are intentionally shaped and worked into a specific form, or they can be expedient, meaning they are barely shaped, but can be worked to produce a sharp edge. Examples of formal tools would be these projectile points. You can see they are carefully chipped into a specific shape. An expedient tool would be these scrapers that is formed from flakes removed from a core, or the spearin used to carve wood and bone. You should note that each of these stone tools industries we discussed begin with a stone core. A core is a large chunk of material used to create stone tools. In North American tool industries, the main material of choice is chert, otherwise known as flint. This mineral is naturally occurring and can be found in most regions of the United States. One fun fact is that flint is Ohio's state gemstone. Flint cores are quarried or recovered from rivers and streams, having been loosened by glacial movement. Other materials used to create chipstone tools include variations of quartz, basalt, and obsidian or volcanic glass. These stones have a cryptocrystalline structure, meaning they contain small crystals that can be easily separated and broken. Once cores are procured, manufacture of stone tools can begin by chipping away or reducing cores into blanks, preforms, and eventually stone tools. This process is known as flint knapping. There are two primary modes of reduction: freehand reduction and bipolar reduction. Freehand reduction is the most common method we see in flint knapping videos and demonstrations. In this method, a core is held and flakes are systematically removed, first by using a hard hammer with the hammerstone and then shaped using soft hammers such as bone or wood implements. The napper is free to twist and target certain areas of the core or blank to shape it into a tool. This method is primarily used in the production of formal stone tools. The second mode of reduction is bipolar reduction. Here the flint napper places the core on an anvil and then strikes the core with a hammerstone to produce flakes. Flakes that are large or useful can then be shaped using soft hammer reduction. This method is much less precise, but is more efficient for producing expedient stone tools. The flakes or waste material from stone tool production are called debitage. They could be used to identify different stages of stone tool production and reduction. From the primary production flakes, we get a great deal of cortex, which is the outer coating of a chert core, and large flakes. Secondary flakes are also large, but contain less cortex. The final stage of production yields thin or small flakes, usually called thinning, finishing, or tertiary flakes. Stone tools are often multi-purpose. Take, for instance, the Clovis point, a point characteristic of the Paleo-Indian period. This tool was used as a spear point, but also was used for cutting meat like a knife and skidding hide like a scraper. We can tell these uses by looking at microwear, the microscopic traces of use on the edge of stone tools. Stone tools also have a lifespan and can morph and change. For instance, the projectile point on the left-hand side of the screen was worn down and used to create a scraper. The projectile point on the right-hand side of the screen was also resharpened and played a second life as a drill. Projectile points are of particular interest to archaeologists because they change shape over time, and we can track that change in morphology or shape to different time periods. Tools that have a particular shape and size are diagnostic, meaning that they are connected to a specific culture and/or time period. Take a look at all the diagnostic projectile points in this image. How do they vary, and how are they the same? Some characteristics we look at, in particular when characterizing stone tools, are the shapes and sizes of the base or stem, the tang or neck, and the barbs or shoulders, as well as the length and thickness of the blade. Changing course now, we move to groundstone tools, which have been around as long as our non-human ancestors have been around. Groundstone tools are typically made from strong, coarse ground stones like basalt, granite, sandstone, limestone, and rhyolite. They are primarily used for chopping, grinding, chipping, smashing, and smoothing. The process of creating groundstone tools is simple. The stone is worn down, whether by repeated grinding against a hard stone or with the aid of sand to increase wear. Some groundstones are polished and others aren't, but become so with repeated use. Some common groundstone tools we still see today are the mortar and pestle, a common kitchen appliance that we actually use today to grind spices, but in this case was used to grind grains and corn into flour. Hammerstones are also common and work the same as a wood and metal hammer you have in the garage. They are used to pound and smash. Stone axes, celts, or adzes are common groundstone tools. These tools were hafted onto handles and used to fell trees. We also often see hoes used to till soil. Based on the chipped and groundstone tool artifacts that we find at archaeological sites, we can tell a lot about what was going on there. Now, if we find a site with groundstone tools used for grinding, like in Site 1, we can probably guess that the site was used for food processing and production, including the smashing of nuts and the grinding of grain for flour. If we see a site that's loaded with debitage and flakes, with few tools and many hammerstones, we might guess that it was a lithic production area. The people here were producing stone tools and carrying out the different reduction processes. As you can see, both chipped and groundstone tools have modern-day equivalents and many uses, and they connect us to prehistoric peoples. The peoples in the past were able to take materials that they needed from the environment and produce tools that were both efficient and sustainable. How does this compare to tools we have today? Can we say that we are actually more technologically efficient than prehistoric peoples? What do you think? Let's discuss it in this week's discussion board.